All right, welcome to Mike Caulfield's early morning info literacy hoedown. It is dark outside, and we're going to try this one. So first, a little bit about how I make these things, in case you're wondering. This is not a real post, in case you can't tell. I generally find stuff on the web, and then I create an example that is based on the stuff. So this one here was based on something I saw back in August, I think. About a Harvard professor. This is the real Harvard professor's name, Dr. Avi Loeb, directs the Galileo project, saying that a comet, an interstellar comet, only the third interstellar object we know of entering our solar system, Loeb is saying, hey, you know what? This might actually be a hostile alien weapon or intelligence or something sent here by an alien intelligence. We should be thinking about that. At least I think that's what he's saying. And so we have this mocked up here. And so let's just take this and let's just put the full thing here. So, and then we're going to just hop over to AI mode. We could look at those. I don't want to go back. Okay. Recently sparked debate by suggesting that 3I Atlas, third interstellar object ever discovered, could be hostile alien technology, like a weapon, maybe, that's going to destroy us all. Most astronomers remain skeptical and believe the object is a natural comet. Now, one of the things I'll note here about AI mode is I think it overhedges a lot of times. It doesn't want to say almost all astronomers, right? Or the vast majority. It says most. Most is a safer word. Most could mean, 51%. Most could mean 99%. And you're just going to find that AI across the board, not just AI mode, just hedges a lot. And so think about that as you interpret these answers. Then it goes and it talks about the truth about 3I Atlas, third confirmed object to enter from interstellar space, first spotted on July 1st, hyperbolic trajectory, meaning that it will essentially pass the sun too. And then it goes into Loeb's arguments, his alien hypothesis, right? Saying that the lack of a tail, unexpected brightness, unusual trajectory, and then, so unusual trajectory, which is statistically improbable for a randomly traveling object. You know what I'm going to do? Okay, I'm going to just edit this here. What is the evidence? What was it? 3I Atlas? Now, I lost all the formatting. So let's see if it's able to do that. And then... So you saw what I did there. I just put, what is the evidence against each point about 3I Atlas? Unusual trajectory, unexpected brightness. So let's go through this point by point. And this is what I mean by evidence-focused follow-ups. We're actually asking it here to not just tell us, hey, a lot of astronomers think that this is absolute nonsense. We are asking it to go and tell us what people say about each point here. Is countered by the idea that it may not be random. The galactic disk is roughly aligned with the solar system's elliptic plane. Therefore, it's plausible that interstellar objects ejected from other systems within the galactic disk would naturally have similar trajectories to 3I Atlas. So this is kind of interesting. If I'm understanding what this means, like the galactic disk, if you ever see like the Milky Way, like this galaxy we're in, like you think of that as like having a tilt. Well, I think what this is saying and again, I could be completely wrong here. I think what this is saying is um, the solar system ends up kind of tilted, sort of like the Milky Way is tilted, right? If you think about the Milky Way, it has this sort of disc shape to it, and then all the galaxies in it are going to tend to be on that plane too, which means that something coming out of another solar system, right, is likely on the same plane as it, which I think is pretty cool if I'm understanding that correctly. But again, I am reading this and then I am responding to you all out there. So just please understand that that is the level of understanding I have is trying to do this in the moment here. But I think that's what it's saying. Look, it's probably not. So what Loeb seems to be saying is, look, it doesn't make sense that this object is coming in, like our solar system is tilted like this. It doesn't make sense that this object comes in at the exact same tilt as the solar system, or close to the exact same tilt or whatever. Why didn't the object come in and pass through like that, right? And what I think this is saying is actually you're just going to have a lot of solar systems in other places, right, wherever this came from, are going to have the same tilt as us, because we tend to tilt in the same way the galaxy tilts. If this is wrong, I'm going to have to check after this. And if this is wrong, I'll probably have to delete the whole video. But okay, unexpected brightness. The initial brightness estimates suggested that 3A Atlas was much larger than other interstellar objects. However, it may have appeared much brighter than its solid nucleus would suggest. It's argued that the light we see is dominated by the coma, not the core, which means that so maybe we've misestimated the size of that. We could check on that. Early observations did not show a prominent tail, but later observations detected one. So when he first said this, he said, look, there's no tail on this thing, or there's almost no tail on this thing. That's very, very weird. Like comet, right? Comets have tails. That's in the definition, right? And since then, later observations have detected a tail, right? The tail, it was described as teardrop-shaped cocoon of dust with a faint tail pointing away from the sun, which is characteristics of comets. Now, keep in mind too, this is an interstellar object. It may be different in some ways than the things that come from within our solar system. In a unique chemical signature, so there was a claim. He made this claim of this unique chemical signature, and since it's gotten closer, I think this is recent studies. Since it's gotten closer, we've detected more usual elements in that chemical signature, right? So presence of water, other gases, that sort of thing. So again, a lot of this was based on when it was much further out in the solar system. As it's getting closer, it's a comet, right? Like three of these, two of these are because it was initially detected far away, and that has changed as it's gotten closer. Initial brightness estimates, that's also very early observations, have changed over time. And then this third one is kind of this interesting idea about why it might have come into the solar system, at the angle of what is the orbital plane or whatever it is. So this is really is a good starting point for us, right? And each of these, of course, we can dive into it. So this one here is going to give us it's IFL science, which isn't like a high, like IFL science. It's IFL science is what it is. It's popular writing about science, but it's citing here. A paper that is responding to these claims, and so this is where this galactic disk, which is where most stars are, is nearly in line with the solar system's elliptic plane. Is plausible that ISOs that are thrown out of other systems are similar to these, and then where is this paper? So we have this paper here. So if we want to find out more about that galactic disk hypothesis, we could go into that. But that's 10 minutes of this. That 10 minutes is probably all you need on this. But again, what did we do here? Again, please remember, I'm just responding to things in the moment as I go through them. Please don't take everything I say here as sort of tentative processing of information, but it's important for you to see how I go about processing these things in real time to get a sense of what you might be doing with this technology. And again, we took this, we got it in, we went here, we got this initial thing here where this guy Loeb had raised these 4 points. Rather than look at it in this format, right, where people said, hey, look, it's people are skeptical. We said, look, we want to address each point here, right? Just the way we wanted to deal with it. And so we made we took that, we copied it in, and we edited it and just put in front of everything we dumped in there. What's the evidence against each point about 3i Atlas? And then we put it all in there, and it went through it methodically. And I think one of the interesting things about that is we learned some neat things. We learned this idea of this plane of the galaxy in the solar system. I had never heard that, and I'm probably going to look into that more after this. So, yeah, that's what we're doing. Kind of neat. Other directions you could have taken, like this is a choose your own adventure sort of activity. You may have found interesting things too, and if you did, and if you're looking at this in a class and you found other things that surprised you or intrigued you, share those. I think there's probably 1,000 different things to find here, and that's good. All right, bye.